Okay, anyhow, again I'm repeating because you have tell me everyone the recording is not there. So from the generator end to the load end, if it is coming from generator to load, it is we write it is as positive. Load to generator, it is negative. So if Z2 is in the form of this one, already we got, then Z1 is what? Just place L equals to minus L. Cosine theta is, this will be plus, but sine theta will be minus. From there, we will be getting the expressions. And I think this also I told about the reflection, matched condition, everything I told. Now, lossless transmission line. Again, I'm repeating R and G is 0. These are the primary constants. Please remember what are the primary and secondary constants. Secondary constants are this one. So whenever in the class, in the exams, you have to derive that one. Gamma is nothing but root over R plus J omega L and this one. So R and G is 0. So we will be getting this type of gamma. And gamma is properly imaginary. You can see this is nothing but imaginary term. So no real term is there. And lossless, already we know this alpha is 0, means attenuation is 0. Already you know attenuation should be 0. From plane wave also, you know attenuation should be 0. And beta is coming this one. From there, we have derived the velocity is coming this one. Now, can anyone tell me, if I ask one question, can we arbitrarily choose the value of this L and C, this inductance and capacitance? Can we arbitrarily choose any value? The question is, can we arbitrarily choose the value of L?
Sir, I don't think so because I think velocity is fixed and L and C also should be fixed. Like,
Uh, because what we are getting, V is nothing but 1 by root over LC. So can we arbitrarily choose these two values? The answer is no. Why? The velocity is nothing but what? What velocity? Is almost equals to the
velocity of light, light or some waves, sir. Like,
velocity is fixed. Not light,
yes, sir.
but
Yeah, like that.
it is fixed at some boundary. At some
So like
boundary.
electromagnetic waves, like the velocity of electromagnetic waves are like equal to this thing, right? Light
Right.
also. So we may
Electromagnetic.
take, yeah, yeah. So it is same, right? Velocity of light equal to velocity of light.
Uh, Not actually, because it is flowing in some medium, right? If you remember,
Oh yeah, got it.
this is lossless.
Correct.
It's not free space. So it has some medium. So anyhow, it is fixed at some boundary. But the problem is you cannot say some arbitrary value. Rather, we can say that from the this velocity, we can set this L and C value. So L and C, this product, this is constant at some velocity, at some boundary. This product is always constant. Now, if you remember Z naught, what I told you, it is nothing but root over R plus j omega L divided by G plus j omega C. So what you will be getting, j omega L by j omega C. So it is coming root over LC. Another interesting observation is there. Z naught is coming purely real quantity. It is purely real. No imaginary term is there. But resistance and conductance, these are the real quantity. Your inductance and capacitance has some frequency, and these are the imaginary quantity. But still, we are getting Z naught. We don't have any ohmic resistance. We don't have any real number, but still it is coming purely real. So this is some of the observations. Up to this one, you have to write. Whenever the question is coming about this lossless transmission line, you have to write the primary constants, right? Then you have to derive all the secondary constants like the gamma, then alpha. You have to explain why alpha is 0, what is beta, what is your velocity, and what is your characteristic impedance. Up to this one, you have to write. I will give full marks. But don't just simply derive. Explanation also needed. Students are in the CI, I observed. They are just writing the formula. They are asking me to give full marks. Anyhow, I am giving. But in the semesters and all, they will not give. And you cannot argue them also. So that's why I'm telling. Okay, I think I made this thing point very clear. Now, another thing is there. We started our analysis on lossless transmission line. We want to derive a voltage and current relationship. We want to develop a current and voltage relationship for lossless transmission, because only lossless is there in your syllabus. Okay. All madams are calling. I don't know. Okay. Current and voltage relationship for lossless transmission line. Correct. Now, look here. We know that V of L is nothing but V plus it is power. Acha. I am writing this is gamma. Gamma L, na? Plus V minus it is power minus gamma L. That you know. Now, gamma is what? Alpha plus J beta. For lossless transmission line, it will be purely imaginary. So gamma is nothing but your J beta. So you write V, this is nothing but J beta L plus V minus e to power minus J beta L. Correct? Now you take V plus e to power J beta L as common. So it will be coming 1 plus V minus by V plus e to power minus J twice beta L. Right? Already we solved this one. Now what is this one? This is nothing but your gamma L. So V plus J beta L 1 plus gamma L, not gamma as a function of L. J into twice beta L. Okay. This is your V of L. Up to this is clear, I think. Now, similarly, we want to derive for your current. I of L is equals to V plus by Z naught. You have to practice also these derivations. Otherwise, it will be difficult in exams. So that's why from tomorrow, I will finish everything. I am giving ample amount of time for preparation and all. In the meantime, you can come and ask me any questions. I am not getting any classes. What to do? You take this as common. This is 1 minus V minus. Correct? Divided by B plus it is over minus J into twice beta L. So it will be V plus it is over J beta L divided by Z naught 1 minus gamma L e to power minus J into twice beta L. Okay. So now you see these two equations, equation 1 and equation 2. Okay. another parameter I am introducing, gamma L. I am writing this is equals to some magnitude part and it has some phase part phi of L. I am doing some extra analysis. It is not there in the books, but it will be interesting. Some high level notes I'm doing. Look here, this is some phi and some magnitude. This is the phase part. Phi of L is nothing but phase of gamma L at load end. So we are introducing this thing. And can I write in this form? Replace this gamma L with some magnitude and phase. I'm writing in the another page. So we are getting V of L is equals to V plus e to the power j beta L 1 plus mod of gamma L e to the power j. Now look here. J into twice beta L is there, minus. And here we are getting another plus phi L. So can I write this is nothing but phi L minus twice beta L? Okay. I can write. Similarly, I of L is nothing but V plus e to the power j beta L divided by Z naught 1 minus gamma L e to the power j phi of L minus twice beta L. Okay. We can plot this thing. Again, I'm doing, if you're feeling very tough, you can remove from your mind. 1 second. My idea is to give the full concept. How I can plot this 1 plus this one? Can I plot? Look here. Let's say this magnitude is 1 from here to here. Now phi of L minus twice beta L. We are keeping some generator like that. Some angle is there. This angle we can write this is phi L minus twice beta L. And this angle is moving like a circle. It is moving like a circle. And this radius is nothing but this one, total. This is your magnitude mod of gamma L e to the power j into phi L minus twice beta L. This is the total magnitude. And this is 1 and this is the angle of rotation. Why I'm telling? It is like a motor is rotating, having some phase, and it is rotating towards the generator. It is moving towards generator. Because already we assumed this length and all, we are putting x equals to minus L, correct? And what is the meaning of x equals to minus L? Means it is moving towards the generator. So the rotation will be in this form. And this is your magnitude and all. Now, when this phase, please concentrate everyone. When your V of L will be maximum, can anyone tell me? When V of L is maximum, this term will be maximum. When it will be maximum? When this term, look here, when this term will be nothing but your 1.
Positive value.
It is equals to 1. Correct. Now, if mod of this one, look here, 1 plus this mod, this value is 1. Then what will be your value of I of L? This is going to be 0. Very interesting thing. V of L is maximum. If maximum means mod of some phase, it is coming 1 only. But if it is coming 1, then this is coming 0. So same time, voltage is coming maximum, but current is coming minimum. Can it be possible? Very interesting thing. Because already we know V equals to I into R, where V is almost proportional to I. We know from Ohm's law. Both are same. So if this is maximum, means I should be maximum. But in transmission line, we are getting opposite thing. Voltage is maximum, but the current is minimum. How beautiful it is. In lumped circuit, we are getting voltage maximum, means current goes maximum. But in transmission line, opposite things we are getting. We are getting the voltage to be maximum, but the current is minimum. At the same thing. So in case of transmission line, maximum voltage and maximum current do not locate at the same position. Again, I'm repeating. In transmission line, maximum voltage. Actually, I'm doing this subject in online. This is really pathetic. But I will do in physical class also if I get some time. Maximum voltage and maximum current do not locate at same position. At same position means at the same space it is not there. Rather, they are staggered in space. Staggered means staggering, you know. In jumble, they are staggered in space. So how interesting plot will be.
Sir, how you got that value equal to 1?
Just I'm telling, if V of max, if it is one, when a VL max, then it will be what? E to power j phi, anyhow it is coming 1 only. Because phi, this max means e to power j phi means what? Cos, sinusoidal or sinusoidal value, right? So maximum value is what?
Yes,
1.
sir.
So that I'm telling. So if it is 1, and I am letting that this is also 1. For the instant, you just think that this is 1. Just I'm telling. And the mod of gamma L is what? Reflection coefficient already I told. This maximum value is 1 only, na? ZL minus Z0 by ZL plus Z0. Maximum value is 1. So anyhow, it is coming 1. So 1 plus 1, it is coming 2. But here it is coming 0. That I'm telling.
Yeah, got it.
So look here. If you plot the diagram of the reflected wave, let's say this is the voltage. This is for the voltage. But look at the current. Current will be what? Just opposite. How beautiful it is. So here we are getting Vmax. But look here. Here we are getting I mean. Here we are getting Imax. But here we are getting Vmin. So that I'm telling the staggered in space. So Vmax and Imax are in different position. Vmin and Imin are in different position. And if you see the diagram, it will look like a standing wave. It will look like a standing wave. Means some are incident in this way and some are reflected back. But if you see from some distance, it will look that the waves are standing. They are not moving. It leads to standing wave formation. Look here. The waves are traveling, so there is loss. There is no loss, na? Waves are traveling, but in lossy medium, what it will be? Some attenuation will be there. Correct. So there is no attenuation. But if ZL is equals to Z0, if it is terminated at the characteristic impedance, then you can say reflection is 0. There is no reflection. But it doesn't mean that lossless is equals to no reflection condition.